Absolute value. The formal definition of absolute value is this. The absolute value of A is A, if A is a positive number or naught, but it's negative A if A is less than 0. So that's the formal definition of absolute value. How do we think of absolute value? Absolute value, as I put there, is a distance. If you imagine a number line, you're simply saying, how far away are you from 0? Whether it's positive or negative, doesn't matter. We just want to know how far away we are. So magnitude only, direction not considered. Those who are doing physics, how many physics people? I guess it's similar to the difference between a vector and a scalar. Yeah, okay. So absolute value would be a scalar. All right, so absolute value of -5, well, according to our rule, we're not interested in the negative sign, so that, of course, is just 5. Now, absolute value symbols are simply grouping symbols, same as parentheses, same as braces, brackets, and the rules with those are, of course, you do whatever inside the grouping symbol first. So before we calculate this absolute value, we do the inside calculation first. And so 6 minus 8 minus 2, negative 4. So the answer is 4. Okay. So same sort of thing. We do whatever's inside first. 6 times 3 is 18. 18 minus 20, negative 2. So we have 7 minus the absolute value of negative 2. 7 minus 2, 5. As it is just a grouping symbol, same sort of notation. We don't write a multiplication sign in front of it. We just go 3 lots of the absolute value of negative 6, which is 3 6s, 18. Okay. So how do we deal with equations and inequations when it comes to absolute value? Now we see, it's a very simple one of course, the absolute value of x is equal to 7. And temptation is just to go, oh, x equals 7 or x equals negative 7. I mean, it's a logical answer. Fair enough. But when we get something like this, yes, I could go 2x minus 3 is 7 or 2x minus 3 is negative 7, but I don't. Because I go back to the definition of absolute value. The absolute value of, what pronoun did I use? A, wasn't it? The absolute value of A was either A or negative A. That's where we change the sign. Not on what it's equal to, but the actual absolute value, whatever has the absolute value. So I change the sign here. 2x minus 3 is 7, or the negative 2x minus 3 equals 7. Now, it might sound trivial, and possibly it is. But when we get to inequations, then it becomes really important we do it that way. So let's solve. Left-hand side there, we get 2x equals 10, x is 5. Right-hand side, we get x is negative 2. There's our 2 solutions. And so there's our answer. Okay. What happens if we have algebra on both sides? Well, again, it's the absolute value we change the sign with. So either the 2x plus 6 is 3x minus 1, or the negative of 2x plus 6 is 3x minus 1. X equals 7 on the left-hand side there. The right-hand side gives me x equals negative 1. This sort of equation, it's really important you do what you're always meant to do with equations anyway, but you never do because you're lazy. And what I'm getting at is really important that you check. Because what we've done, in order to solve this equation, is we've changed it to 2 new equations. Now, our answers are answers to the new equations. Are they answers to the original equation? Because yes, sure enough, when you sub in x equals 7, all works nicely. Unfortunately, when you sub in x equals negative 1, it doesn't work. Because on the right-hand side, we end up with negative 4. So we're saying the absolute value of something is negative 4. So yes, it is a solution to the new equation that we created to help us solve the problem. But it's not a solution to the original equation. Check your solutions is what I'm getting at. So that one's no good. The only possibility for this one is x equals 7. When's this problem going to arise? This situation. When you've got absolute value equals, and on the right-hand side, or on the other side, depending on where the absolute value sign is, you have some algebra. A constant number is not going to be a problem, because constant 7 in example 2, not an issue. But it's usually going to happen when you're substituting into the right-hand side as well, because sometimes you'll end up with negative numbers, that's all. So that's the one where you really have to watch out for. Absolute value equals some piece of algebra. That's where it's going to happen, if it's going to happen. Okay, let's have a look at the inequation. So it's the absolute value that we change the sign on. So either x plus 5 is less than 2, or the negative of x plus 5 is less than 2. So x is less than negative 3, or x is greater than negative 7. Number lines can help to solve the problem. So I've got x is less than negative 3. I've got x is greater than negative 7. So it looks like I'm looking for the answers that are in between these two. That's something they've got in common. Of course, you could use the boundary value idea and say, well, look, negative 3, negative 7, they're my key points. Test regions, see what works. You can do that as well. So we've ended up in between for that one. X is less than negative 7. And you can see what's happened. Yeah, you see what's happened. By putting the sign in the wrong spot, my inequality sign for the solution has ended up the wrong way around. So it's the absolute value sign that you change the sign with. So absolute value of 3x plus 2 is greater than or equal to 1. Change it on the 3x plus 2. We get x is greater than or equal to minus a third. We get less than or equal to negative 1. Again, if I just check this on a number line, so this time it's the outside. So similar to those quadratic ones, we tend to get solutions that are either in between or on the outside. So there you go. So the graphs, absolute value graphs, what do they look like? So if we have y equals the absolute value of function x, what does that do to the curve? Well, basically it means y can't be negative. So whatever is below the x-axis, whatever is negative, reflects above the x-axis. The other possibility, more unusual, but you could have function absolute value of x. So now what it's saying is, I only substitute in positive numbers into the function. Because if I was going to substitute in negative 2, the first thing I'm going to do is find the absolute value of negative 2, and now I'm substituting in positive 2. So this has an interesting thing. The original graph, the left-hand side of the y-axis disappears completely, and then whatever is on the right-hand side reflects over. So it becomes an even function. Here, of course, is the basic one, which I hope we all recognise. And there it is. Y is the absolute value of x. It's usually a good idea to label a couple of points on it, gives it a sense of scale. But that's our most basic one. So, all right, we have to draw y equals the absolute value of x plus 2. Now, there's different ways I can think about this. I can say, look, I've got the basic curve of y equals the absolute value of x, but I'm going to shift it, because notice it's grouped, absolute value grouping symbols, it's grouped with the x, so I'm going to shift it horizontally 2 units. And then I get my graph. That's one way I could have thought about that. Another way I could think about it, I could say, no, I'm going to start with the line y equals x plus 2, which would be that line. But then I'm saying I'm going to take the absolute value of that, so whatever is below is reflected above. And we get the same picture. So it doesn't really matter how you think about it, just different ways of thinking about it. Okay. Absolute value of x plus 2. So again, I could think of it as the basic curve, absolute value of x. This time, it's not grouped with the x, it's grouped with the y. So we're going to shift it up 2 units. Says y equals absolute value of x plus 2. Or, again, I can think of it as the line y equals x plus 2, but it's function absolute value of x. So whatever is on the left-hand side disappears, and then the right-hand side reflects over. Again, we get the same picture. Of course, it doesn't have to be straight lines. Absolute value of x squared minus 2. Well, there's x squared minus 2, the parabola that's been shifted down 2 units. We're saying whatever is below is reflected above. Yeah, so there's our shape. Y equals the absolute value of x squared minus 2. I'm not suggesting you would do it this way, but you could. If you wanted to solve the inequality, the absolute value of x plus 5 is less than 2. Well, there's y equals the absolute value of x plus 5. And what we're basically saying is, when is this graph less than 2? Well, it's between these two x values. Now, depending on how accurate you do your graph, they actually intersect at these 2 points. So my solution is I'm in between -7 and -3. The reason I'm saying I probably wouldn't do it that way is I'm still going to have to solve the equation anyway to find the points of intersection. I suppose if I already had the graph, maybe I could do it that way, but I don't know that I'd draw the graph up to actually solve this problem. All right, time for some fun. Yeah.